So today, we're going to do a little bit of review of 3.3, and we're going to do 3.4, finish up 3.4. We're also going to start in on Chapter 5, probability distributions. You have Excel Lab 1 can be turned in late for full credit today. Today is the last day to get full credit for it late. Also, Excel Lab 2 is due today, but you can turn it in late for full credit up to next Thursday. Friday starts your first Connect Math homework, so you have a Connect Math homework on Friday, another one on Sunday, don't forget Sunday's coming up, and then one next Tuesday. So Friday's a little bit weird tomorrow, right? That's because I didn't want it due today. I thought that was a little too soon, but Friday, I'll give you an extra day for that one. And then also on Tuesday, Excel Lab 3 is due. I decided to switch that with Lab 4 because we've done Chapter 3, so we can do Lab 3, and it kind of makes more sense to do them in order. So we'll do that one. And then next Thursday, you have Connect Math 5. You're starting with Chapter 5 coming in due. There's been no class on Monday. So remember I told you every couple weeks I'm going to try to get so you guys can have only 2 days a week to kind of give yourselves a little bit of a break. So Monday, I'm giving you guys off. Does anybody want to come in anyways and get some help? Because I'm happy to come in if people want to come in. That sounds like a no. Okay, sounds good. Well, so relax a little bit, and just de-stress. Take care of your other stuff that you need to take care of, and that's pretty good. Okay, perfect. Speaking of actually things, break on things. Oh yeah, no, that's okay. You guys are going to be normal. So yeah, your next exam is going to be October 28th, which is a Thursday. It's Flex Day, but Flex Day ends at 4. So you'll have your exam at 5. And then I'm going to give you guys the day after Halloween off.
Oh, yes.
So that seems good. Now, however, if you would like to, instead of taking your exam on Thursday, if you're not going to party on Halloween anyways and you want the extra time to study, then you can take the exam on November 1st instead. We can talk about that. Everyone's like, no. Okay. All right, well, it's an optional. We'll talk about that as we get closer. But don't come on Monday then. Just relax, de-stress, get your other work done, right? Your classwork done, or homework done. All right, range rule of thumb for estimating the minimum and maximum usual value. Remember, so what we're saying is that from the mean, if you subtract 2 standard deviations, that is sort of your minimum usual value. From the mean, if you add 2 standard deviations, that's your maximum usual value. So if you go 2 this way, 2 that way from the mean, those are your minimum and maximum usual values. Good? So you subtract 2 standard deviations, add 2 standard deviations. So this is your quiz problem number 1. So I'm going to find 2 standard deviations. So I'll draw a picture too. We'll do both. So here is 678.4, and I want to go 2 standard deviations this way and 2 standard deviations that way. So I'm going to do plus 41.1, plus 41.1, minus 41.1, minus 41.1. Or you could just find 2 standard deviations, right? So 2 SD is equal to 2 times 41.1. That's 82.2. So my minimum would be my mean. My mean is this 678.4 minus 82.2. So that's I'll give you the formula to you while we're at it. We'll do the whole piece. So it's the mean minus 2 SDs, right? So that's 678.4 minus 82.2. So that is 596.2. The max is the mean plus 2 standard deviations. So it's 678.4 plus 82.2. So that would be 2, 8, 770? 760. 760.6?
Yeah.
Yeah.
Good. Great. All right. All right, so that's this number here, 760.6. 596.2. You can find it either way. Would a book with 620 pages be unusual? 620. Where does 620 pages fall? Like right here. Totally not unusual. It's between these two values, right? So it's not unusual. Good? See, like right here. It's totally not unusual. Coefficient of variation. This is actually in 3.2. So some of your quiz is 3.2. It's the ratio of your standard deviation to your mean. In other words, what percentage of the whole is your standard deviation? So you just take your S, divide by X bar, change it to a percent. Does anyone need like 15 seconds to do this? You guys all got it? Okay. That's great. So this is going to be, so this is my N. I don't need that. This is my mean, so this is my X bar. And this is my S squared, I don't need that. But this is my S, I do need that. So it's going to be S over square root of, over X bar. So it's going to be 4 over 65, which is 0.06. Keep going. What was that? One more? 5? Great. And then, so this is, what is this in percent? So find the cents spot. So the penny spot is the 6. So it's going to be 6% plus a little extra, right? So that's kind of how I figure it out. So it's going to be 6%, so 6.15%. That tells me kind of where to put the decimal place. Okay, good. Great. Moving on. Chevy Chevs. Yay, Chevy Chevs. Chevy Chevs, remember, Chevy Chevs is powerful because it applies to any data set. It does not have to be normal at all. It can be numbers you made up. What it says is, from the mean, if you subtract 2 standard deviations or add 2 standard deviations, or 1 over k standard deviations squared, then two standard deviations, at least 75% data is going to fall within 2 standard deviations. If I go 3 standard deviations in either direction, then between these two values, at least 88.9% of data will fall between those two values. It's a little more, there's a lot of other values in between, but we're just going to focus on these two. 2 standard deviations and 3 standard deviations. So, that leads us to problem number 3. Does anybody need 30 seconds to do problem number 3? No? Okay. All right, so what percentage lies within 3 standard deviations of the mean? 89%, or you might say 88.9%. Either one's fine. It's all good. 75% of light bulbs lie within 2 standard deviations. Great. So that is, let's see. Yep. 600 minus, that's 300. Plus 900. What am I plussing? I'm plussing a standard deviation. All right, this is my S. This is my X bar. So 300, and if you add 2 standard deviations, you get to 900. Great. All right, the empirical rule. So Chevy Chevs is great because it applies to any data. However, the empirical rule is only applies to normal distributions, but if it is normal distributed, we can do way better than Chevy-Chev. Chevy-Chev says at least 75% lies within 2 standard deviations. That means anywhere from 75% to 100%, this big range. If it's normally distributed, empirical rule says right around 95%. So not between 75% and 100%, but right around 95%. It's a lot more specific. For 3 standard deviations, Chevy-Chev says 89% or more, right? So 89% to 100%. If it's normally distributed, empirical rule says right around 99.7%. It's a lot more specific. And empirical rule, Chevy-Chev says nothing about 1 standard deviation. But empirical rule says right around 68% will lie within 1 standard deviation. So pictorially, looks like this. Now you can see it's normally distributed. So within 1 standard deviation from the mean. So between these 2 values, approximately 68%. 2 standard deviations in either direction, so between these 2 values, approximately 95%. And 3 standard deviations between those 2 values, approximately 99.7%. Does anybody want just a minute or 30 seconds to do? Yep, so just take 60 seconds and you know what I'll do? Yeah. Yep. I'll work on that one. I'm going to put up the information you need for z-scores in case you didn't do number 5 as well. Okay, so there's a couple ways of doing this. Some people just subtract the standard deviations, right? So you could do it this way, where you just add in standard deviations, you make yourself a little table. Other people, what they did was they said, well, let me find the z-scores. So they found the z-score for 159 and said 159 minus the mean divided by standard deviation, and they got -1. And they found the z-score of this one minus the mean divided by standard deviation, and they got +1. So they said it's between -1 and +1. Or they could have done it this way and said, oh, it's between -1, -1 standard deviation plus 1 standard deviation. But within 1 standard deviations, what percentage lie within 1 standard deviation? 68%. Okay, and the next one, you can find it either way, but you'll see that that's 2 standard deviations. So that would be what percent? 95%. You can do it either way. Either way totally works. Either do it by drawing the picture and counting how many standard deviations you are away from the mean, or do it by finding the z-scores, and I'll tell you how many standard deviations each one is from the mean. All right, now we're going to talk about z-scores, percentiles, and quartiles. First of all, do you guys remember population mean, population standard deviation, sample mean, sample standard deviation? What are those symbols?
X bar is.
X bar is your sample mean. Great. Someone else give me one. You is what? Population mean. Someone else give me another one. Sigma. Sigma is the population standard deviation. That's a circle with a little tail. And what's the last one? Sample standard deviation?
S.
S. Remember, population, those guys are the Greek letters. The sample ones, those are the regular ordinary letters. Which ones are statistics?
Sample.
Yeah, the sample ones are statistics. And the parameters are the ones for the population, exactly. All right. Z-values. How do I find Z-values? First, remember what it is last class. First, you figure out how far your value is away from the mean. If it's above the mean, it's positive. If it's below the mean, it's negative. That distance is negative. And then you divide by a standard deviation to get that in terms of standard deviations. A z-score represents the number of standard deviations a value is above or below the mean. It's really important you know that. What's the probability that I'm going to ask you that on the exam?
100%.
100%. So everybody's going to say this, the first two lines only in blue with me. I'm going to say them together. Ready? 1, 2, 3. A z-score represents, hold up everybody. Okay, try it again. Everybody, ready? Oh, sorry. 1, 2, 3. A z-score represents the number of standard deviations that is above or below the mean. Perfect. It's really important you know this. And notice how many standard deviations are you above the mean, or how many standard deviations are you below the mean? Don't forget, for any value, every value corresponds to exactly one z-score, and every z-score corresponds to exactly one value for any given problem, right, for any given mean and standard deviation. Right. We will see that more as we go. How do you find a z-score? Well, you take your value, you subtract the mean to see how far you are from the mean. That way, if you're above the mean, you're positive. If you're below the mean, you're negative. And then you divide by a standard deviation to get it in terms of standard deviations. Symbolically, it's your z-score is your value, x, that you care about, minus the mean divided by a standard deviation. This is, I think, page 3 on your notes. Is that right?
Yeah.
And if you did not put this in yesterday, which you should have, put it in now. It's for a sample, x minus, what's my sample mean?
X bar.
X bar, divided by my sample standard deviation,
S.
S. So that it should be right next to this other formula. You should write that in on page 3 of your notes.
What is that looking at here?
The notes are,
I was gonna.
they're in the back corner over there.
Oh.
You weren't here last class. Okay, so anytime you're not here in a class, the previous class's handouts are on the table against the wall, so make sure you snag those. All right, so typically people have a hard time wrapping their heads around the idea of a z-score. All right, so sometimes it's helpful to think of it as like car lengths, right? Because we've all heard like, say 3 car lengths behind the car in front of you when you learn how to drive, right? You guys all remember that? So we're kind of used to the idea of like counting car lengths. So it's sort of like that. You can, if it helps you, think of them like that. Here's my mean. How many car lengths am I from it? Away from it? 1.72. Right? So if it's helpful to kind of visualize it in that way, you can totally do that and think of it, just as, in terms of it's. In terms of that, and just remember that every problem is different, right? For every problem, you got a different standard deviation. Some standard deviations will be kind of regular shaped. Some will be really small. Some will be really large, depending on the problem itself. If you guys remember, RT, I think it was in this class she mentioned, she likes to think of it in terms of steps, right? She kind of thinks of it like, how many steps away am I from the mean? And depending on standard deviation, maybe you take a larger step or you take a smaller step. But your steps should kind of all be the same size. Like I take, this much of a step each time, and how many steps am I away from it? If that helps you think about it, that totally works too. Okay, so your quiz problem 5, you're supposed to find the z-scores for each of these problems. So let's see. We have score of 81. This is my first x value for psychology. So what else do I have? I have a mean of 89. That's my x bar. And I have a standard deviation of 6. That's my s. So my x, this is for psych. My x is 81. X bar is 89. S is 6. So my z-score for psychology will be 81 minus 89. my value minus the mean divided by standard deviation. And it better be negative because I'm below the mean, right? So make sure you sort that out. So 8 over 6, negative 1.33. Typically give them 2 decimal places, usually z-score. The other one is 42, that's the econ. That's my x for the econ. And then my mean is 50. Standard deviation is 8. So my x bar is 50. Standard deviation is 8. So my z-score for econ is 42 minus 50 over 8, which is negative 1. Okay, so which one's better? Which would you rather be? 1 standard deviation below the mean or 1.33 standard deviations below the mean? 1. You'd rather do only 1 below the mean. So the econ is relatively better. Then we talked about last class about percentiles. Remember, percentiles split our data into 100 equal pieces called percentiles. And the idea is your percentile is the percent of people who you beat, who you're higher than. So you can never be the 100th percentile because you can never beat yourself. All right, so how do you find it? You figure out how many people are less than you out of the total, divide by the total number of people, and then you change that to a percent, or percentile, multiply by 100% percentile. If you just use the book does it slightly differently. They say that here's me, and I'm cutting myself in half, so that I beat half of me, I'm higher than half of me, and I'm below the other half of me. Does that kind of make sense? So they're kind of splitting you in half. So if I beat 3 people, the book would say you beat 3.5 because you beat half of yourself. So you can use either one. But here is your problem here. Below, so what's percentile correspond to age 36? Who wants just another minute to finish this one up? Everybody's totally done with this? Okay, so I am here, 36. That means I beat this many people. I beat 8 people. I beat 8 people out of how many?
36.
Out of 36. So that is what?
22?
22?
22.
Yeah, so 0.222 as a percent. Because it's going to be my percent spot, it's going to be 22, kind of 22%, so it's going to be the 22nd percentile. And yes, I want you to use the word percentile because I'm asking you for the percentile, not the percent. Good? Because percentile implies also that that's the percent that you beat. It kind of wraps all that information in there. Your study guide, I might have given a decimal in there. You can have 1 decimal or not. That's totally fine. Make sure you round correctly. If this was 5 or more, then it would be 23rd percentile. Everybody are on board with that part? Like I said, again, you got to look at the next decimal and round correctly. If this last 2 was a 5 or a 6, it'd be 23 percentile. Yep.
When do we multiply it by 100, like it says in the...
Anytime you want, before the end.
Oh.
So I just found it here and then I changed it to a percent. So
Oh.
that's the percent. Yeah. But I like to think of it as, what's the decimal number of people I beat? Okay, what is that as a percent? That's the percentile. Percent and percentile kind of, they stand for the same thing. Just this is I want you to use the word percentile specifically, not just the symbol percent. All right, so then, this is kind of where we left off a little bit yesterday. So we talked about the other way around. So if we have a percentile, they call percentile K, Kth percentile, and you want to find out who you are, that's undoing it all, right? So here's the formula, it's the same formula, because your formula was the percentile you are is equal to the people that are lower than you, divided by how many there are times 100. So how do you solve for L, the number of people lower than you? Well, you multiply both sides by n, and you divide both sides by 100. And that's how you get that from. And that will tell you how many people are lower than you. It doesn't tell you who you are, where your spot is. It tells you how many people are below you. So, here's our example. Okay, we want to know which one is the 25th percentile. So 25 out of 100 multiplied by my n times 10. That means that's 2.5. That means I beat 2.5 people. If I beat 2.5 people, who am I? I'm the third person. So if I'm the third person, that means I beat 2 people, I beat 2.1 people, I beat all the way up to 2.99 people. Everybody all right at that part? I don't beat 1.9 people because that would be the second person. They beat 1.9 people. I don't beat 3 people because that would be the fourth person beats 3 people. So that sort of makes sense? I'm the third person. I beat up to 2.99 people. So I'm the third person. I'm number 5. The third spot. So the third spot tells you your location, your position. Doesn't tell you what you are. It's not saying I am 3. I'm saying I'm the third one. I'm in the third position. These are all measures of position. So it means I'm in the third position. I'm number 5. Good. So the L tells you how many people you beat. So then you're the next position. Doesn't tell you what you are. It tells you what position you're in. All right. So you guys are going to do lab problem 4. You're going to find what number here corresponds to the 15th percentile.